Hey, I'm Ryan with Warner Discovers, and today I'm going to show you a fix that I found that resolves a cooling issue I had when we encounter extremely high heat temperatures outside. Now, if you have an indoor ducted Mitsubishi unit that you've been having trouble with high temperatures with, definitely follow along and see if this helps you. So let me just describe my scenario. This may be a little bit of a niche solution for people, but I really hope this helps somebody else because I've been dying to get to the bottom of this for 2 years now. So to describe my scenario, about 2 years ago we got Mitsubishi heat pumps installed. We have the house here, and then outside we have a Mitsubishi heat pump which goes up into the attic where there is an indoor ducted unit which spits out cold air throughout the rooms on the second floor. This also connects to a wall unit on the first floor. So this unit on the outside controls both one unit on the first floor and an indoor ducted air handler on the second floor, or basically the attic. Now this situation works totally fine about 80% of the time. However, the main issue comes when it gets extremely hot outside. When it gets over 90 degrees, the system definitely starts to drag. I also want to point out the ducted air handler in here is also in an uninsulated area, so it's a poorly insulated attic, unfortunately, so it is experiencing high temperatures. Normally, before any of my assistants in the attic, it could potentially get up to like 130 in the attic. Now this works fine most of the time, but during the summer, it starts to really drag down when it gets above 90 degrees, 95 degrees, and if you hit like 100 degrees outside, this is just stalled. Now I'll show you a couple measurements that I took between the delta, which is just the return and supply air coming in. You can see here there's a picture of the return showing 76 degrees, testing with one of the thermostat probes, as well as an infrared thermometer, and then another picture with the supply, which is actually blowing out only 72 degrees Fahrenheit. So with a delta of only roughly 4 degrees. So this is driving me crazy because it would take forever to cool down in the middle of the night. Now just to show you how much of a trouble it was when it gets hot outside for that system to cool down my second floor, we can take a look here. On June 23rd, for approximately 3 days, it was a very high temperature forecast. So you can see here the bottom line is the master bedroom temperature on the second floor, and the blue line is the outside temperature. On June 23rd, you can see that it's 88 degrees outside, and the master bedroom at 7 o'clock is at 72 degrees. So it's been struggling to keep up most of the day. And as we continue into the night, it's slowly bringing the temperature back down, although even by 6 or 7 a.m., the master bedroom never even attempted to get to 68 degrees, which is what it's usually set to for nighttime temperatures. June 24th, it's 101 degrees outside at 2 p.m., and this is at the point where the second floor will start getting extremely hot. So you can see the master bedroom temperature rising over the course of the afternoon. By 8 p.m., we're almost at 76 degrees. And by 1 a.m. that night, it actually ended up reaching 77 degrees. And going throughout the night, the system still won't keep up. It's still trying to cool down all the way until 7 in the morning the next day, where it's 81 degrees out. It never got below 72 degrees. Continuing on to the next day at 2 p.m., it's another high heat day. It gets to be up to 93, 94 degrees out. Master bedroom back up to 75 degrees in the middle of the day. Again, hasn't dropped below 70 degrees or 72 degrees in the past day and a half. Continuing on into the night, you can see now that the outside temperature is falling. The master bedroom is also falling at a similar rate. And by the 26th at 8 a.m., we finally reach 68 degrees, and you can see the lines converge from there. Now this is a typical situation for a high heat day. The system struggles keeping up, and I never got a solution. After this happened so many times, I started to research this once again, and I found a post by somebody on greenbuildingadvisors.com where they actually spent hours on the phone with a tech and Mitsubishi to come to this switch setting. Now what they were able to figure out is for a high humid area, so for me up near the Boston region, where we experience high humidity, high heat, cold temperatures, this particular setting seemed to help, and for them it actually resolved the entire issue. So on the outdoor unit there is dip switches, and in particular there's 2 dip switches to take note of, SW6-7 and SW6-8. Configuring those two switches actually set the ETM temperature. And what that is the evaporator target temperature. And that is the target temperature that it shoots for the middle coil on the indoor unit to maintain while cooling. Now by default, those dip switches are set to false. And as you can see here in the PDF, depending on if you set one to true, one to false, you can actually end up setting 4 different temperatures. By default, it's set to 9 degrees Celsius. So what we're gonna go ahead and do is set the SW6-8 to on, which will result in changing the middle coil target temperature to 6 degrees Celsius. So let's go ahead and see how that goes. So I'm out here with the Mitsubishi outdoor unit. I've got this screw and that screw down there, and then this one at the top. And then this part should come right off. Now once you take those screws off, you have the panel off, and here you can see the control board, and definitely make sure you pull your fuse and make sure that the lights are all off before messing with this. Now up at the top here you can see some switches, and these are all dip switches, and what we're going to do is change SW6, and you can see in that box here SW6 has 1 through 8 dip switches, and up is on and down is off. So what we're going to do is change SW6, 7, and 8, and those will change those ETM parameters. In my case, I'm going to switch SW6-8, so it's this bottom one right here. I'm going to push it up to the on position. Now you can see that SW6-8 is in the on position, so now the ETM will be set to 6 degrees Celsius. Now you can flip this flat back down and align these to the side slots and put the cover back on. So as you can see, that's pretty straightforward. All you need is a Phillips screwdriver and a small flathead just to change that dip switch. Now upon doing this, I can actually say that this has completely resolved our issue. On July 28th, we had a high of 93. The attic ended up getting up to 108 in the attic, and we were returning 72.6 Fahrenheit cold air, and we were blowing out between 60, 61, 63 Fahrenheit cold air. The next day, July 29th, we had a high of 100 degrees, clear sky. It was actually 118 in the attic, and the register was returning 71 degrees Fahrenheit, and it was blowing 59 degrees Fahrenheit, which would have never happened before. And then finally on the third day, it was also a high of 95, clear sky, 114 in the attic, and we were returning 72 degrees, and we were blowing 55 and 59 degrees up on that second floor. Now if we look back in Home Assistant, we can look at those 3 days, July 28th to the 30th, and you can see the outside temperature and the master bedroom temperature once again, and the outside temperature skyrockets up to 100 degrees outside, and the master bedroom is still at 70, 71, but it never even gets above 71 and goes all the way down to 68 degrees, as you can see there, where before it wouldn't even get below 72 during that 3-day heat cycle. And once again, getting extremely hot up to 96, 97 degrees in the master bedroom, maintaining its target temperature during the day of 70 degrees, and then later dips down at night, achieving the target temperature. So if you're in a similar climate and have an indoor ducted Mitsubishi unit in the attic, and it is in an uninsulated high heat area, definitely give this a try. Like I said, it pretty much resolved all my issues we were having with the high heat days. Of course, a better solution is insulating the entire attic, but it's much more costly and much more of an in-depth project. I've tried to lower the temperatures in the attic, which obviously will give you more efficiency, but this in the meantime at a cost of energy just to get more performance out of the system to offset those really hot days is a great solution, and I'm really glad to get to the bottom of it. So shout out to those people who shared their experiences on this Green Building Advisors link. I'll put in the description. I'll put my model numbers in the description of the types of units that I'm working with. And please let me know if this helped you. This is a really simple fix, and I really wish more people knew about this because I feel like a lot of other people are running into this same issue online and cannot get to the answers that they need. And let me know if there's anybody who has more information on this evaporator target temperature functionality. But for now, I'm gonna stick with this setting and really enjoy the benefits of our system. Thanks so much for watching, and let me know if you have any more questions.